Hello everyone, and welcome back to our channel. I'm really excited to share something special with you today. It's a project I've been working on called RIDE. It is a ride-sharing platform designed to revolutionize the way we travel and connect with others. It is more just than an app. It is a smart system that efficiently matches drivers with passengers, optimizes routes, and ensures a seamless transaction for me. So, before we start into our technical details, let me give you a glimpse of what RIDE offers. So now I'm going to explain you the features of my application. The first feature is efficient driver-passenger matching. When you open Riding and request a ride, what happens behind the scene is pure magic. Our system efficiently matches the driver with passengers. You may ask the question how? Well, we use something called priority queue and SWOT algorithm. This high-speed matching minimizes wait time and maximizes ride availability. So the next feature is optimized route calculation. Now, once you're in the car, our motive is to get you to the destination in quickest, most fuel-efficient way possible. Our platform calculates the most optimal routes. It considers things like distance, traffic condition, and even your time concept. When these things are considered, it reduces the travel time, which means you get there faster and minimize fuel consumption, which is greater for environment as fuel is consumed less and you go to the destination as fast as possible. And the last feature is real-time demand management. Have you ever wondered how to get matched with drivers so fast? That's all thanks to our real-time demand management. We handle passenger requests in real time. As soon as you request a ride, we promptly assign it to you when a driver is available. But if our drivers are busy, don't worry. We manage a queue for passengers. So you're in a line and ready to go as soon as the driver becomes free. So let me tell you the data structures that I've used in this project RIDO. The first data structure that I've used in this project is graph. I'm going to explain why this graph is going to be used. So imagine there is a city with complex road and network, and the roads are filled with streets, intersection, and highways. Now graphs are like map that help us to represent the connection between different locations. So when you book a ride, this is what's behind the scene to find the fastest route from point A to B. So let's keep this as an example. If a person wants to go from, let's keep this position to G position. Let's keep this is 8 kilometer, 5, 2, 3, 4, or let's keep 4. So if a person wants to go A to G, we should find the minimum path from A to G. Let's keep A to C, then C to F, then F to G. This is the minimum path that a person can go in a map. This is where graph is used to connect the different states and different pathways. So now let's talk about priority queues. So have you wondered how you get matched with driver or passenger so quickly on a ride sharing app? So it's all thanks to the priority queue. They are like a special list that help efficiently manage real time demand. So now let me explain you a real time example. Let's keep this is a ticket counter. These are the persons standing in a queue. So the person who stands first will get the ticket first, and the person who stands last will get the ticket last. This is the operation which will be done in queue. So there are two operations which are done in queue, that is NQ and DQ. NQ is nothing but adding value at the last. DQ is nothing but deleting or removing element from the queue. This will be done at the top. So we have used priority queue, which removes the element according to their priority. So if this element has higher priority, this element will be removed first, and the element at last will remain at last. And when the element get deleted, this will get moved at the top. And this is how priority queue is in. So now let's dive into HashMap. These are like magical digital address books. When you book a ride, you have seen your driver details, right? Hash maps are what you store and retrieve information about drivers and passengers. Example like their location and contact details. So now I will explain you about hash map. Hash map is nothing but a collection of key value pair where each key is an unique number and its map specifies to a specific value. The primary idea behind a hash map is to provide efficient and fast retrieval of data. Here's how hash map works. So when we enter a key, the key is converted into hash function. This hash function is used to access the element in an array where the data is stored. So hash map use array to maintain a element or the values. It can be stored in using indexes. So there are three types of operation done in hash map. The three types are insertion, retrieval, and deletion. When you want to add a key value pair to hash map, the hashing function is applied to the key to compute the index in an array where the key value should be stored. If there's already a value at the index, for example, if you have a value at this index, various techniques can be used to handle that, such as chaining or opening address. The second operation is retrieval. When you want to retrieve a value, you provide the key and the hashing function is used to find the index where the value should be stored. Then you can access the value stored at the index. And the third function is delete. To remove a key value pair, you should use the key to find the index and then remove the value of the index. So this is the code where it primarily computes the total cost of the fare of the ride and it takes various parameters. The functionality of the code follows. So first we include the studio.h. So it allows us to take input and output. The next we derive a variable using integer and the variable names is drivers and we assign it a value that is 12. Next, we are about to see a function which calculates the cost. This function calculates the total cost of the ride. These accept three parameters: distance, peak fee, and type fee. The total cost is initially computed with a base fare of 50 rupees and the rate is initialized to 10 rupees per kilometer. Then total is multiplied with the type of the fee. The type of the fee decides according to the type of the vehicle. And the peak fee is nothing but if there is a demand in a specific area, it calculates according to the demand and the availability of drivers. Next there is a next there is a function which check the rush. This function applies a surge pricing based on the number of available drivers. The logic works like this: if number of drivers greater than 10, if number of drivers greater than 10, it returns the value 1. Then if the driver value of the drivers is greater than or less than 3, it returns 1.5. If it is not in the both condition, it returns 1.2. Now, as we see in the main function, it asks the user the input of distance and type of the ride. Now it updates the number of drivers to 7 and it calculates the peak fee using checkers function. Then it calls the cost calculation function using these updated parameters and it calculates total cost of the rides and prints it. Therefore, this script simulates a basic ride fare calculation system like one by used by ride hailing application. So let me show you the output of cost estimation code. The first is ask for the distance and next it asks for the type of ride. Let's give it a 2. So now it will print the total cost of the ride according to the distance and the type of the ride. And this is digital algorithm code. It is used to find shortest path between two nodes. The first we create a structure node and it represents a node in the graph. It contains three fields: the destination vertex and the edge weight and the next. It is a pointer to the next node in the linked list. This structure is used to construct the adjacency list for each vertex. Next is the adjacency list structure. It represents the adjacency list for a vertex, and it also contains a pointer to the head of the linked list. The next structure is graph. It represents the entire graph, and it includes the number of vertex v, an array of adjacency list, and each element of the array corresponds to vertex in the graph. And create node is a function which is used to create a node. It takes two parameter destination and the edge weight, and it returns a pointer to newly created node. The next function is create graph, and this function initializes a graph. It takes the number of vertices as a parameter, and it allocates memory for a graph structure and initializes an array of adjacency list. Each list is initialized with null head, indicating that initially there are no edges. So the next function is adding edge function. It is used to add an edge between two vertices in the graph. It takes graph and source vertex and destination vertex and the edge weight as their parameters. It creates two nodes with provided destination and weight, and adds one node to the adjacency list of the source vertex and other to the destination vertex. This function constructs a graph structure by establishing the connection between the vertex. Now next we are going to print the graph. It is used to print the adjacency list represented of the graph. It iterates through each vertex in the graph and its associated linked list, printing the destination vertex and edge vertex. This is useful for visualizing the graph structure. Next comes the main function Dijkstra algorithm. Dijkstra is the implementation of Dijkstra algorithm for finding the shortest path from source vertex to all other vertex in the graph. It initializes an array for storing the distance from source vertex and whether a vertex is part of the shortest path tree or not. It starts with source vertex and initially explores and to updates the distance to other vertex, selecting the vertex with minimum distance in each iteration. The result is an array from the source vertex to all other vertex in the graph. Now, as you can see in the main function, a graph with 5 vertices is created. The edges associated with this are added to this graph, efficiently creating a weighted graph. Print graph function is used, or it is called, to display the adjacency list representation of the graph. It helps to visualize the graph structure. Dijkstra function is used to find the shortest path from the source vertex to all other vertex. The result prints the shortest distance. So this is the output of Dijkstra algorithm. So this code, it is used to match the passenger and the driver. So this code begins by defining three important structure. The first structure is user. It represents a user with their ID and their priority, as this is a priority queue. The next structure is driver. It represents a driver with ID and it also represents the priority. And same goes to the structure node. So the next structure is node. It represents a node in the priority queue. It contains a pointer to either the user or a driver, and it also contains a reference node to the next node in the queue. So next structure is priority queue. It represents the priority queue itself with a pointer to front node. So next we are initializing a priority queue. The in priority queue function initializes an empty priority queue and returns a pointer to it. Next, we are creating a function which enqueues the data. That enqueue data function is used to add a user or driver to the priority queue. It takes the queue, the data to be enqueued, and its priority as the parameter. A new node
is created with the provided data and the priority. If the queue is empty or the data has higher priority than the current front the queue, the new node is inserted at the front. If the new data's priority is low or equal to the current node, the function iterates through the queue to find the approximate position to maintain priority order. So next is print queue function. It prints the content of the priority queue, either it is users or it is drivers. It traverses the queue and prints the ID and priority of each element of the data. And the next function is DQ function. DQ function, it is used to remove the highest priority user or driver from the queue and return a pointer to the DQ data. It follows three steps. If the queue is empty, it returns null, indicating that queue is empty. Otherwise, it iterates through the queue until the end to find the last node, which holds the highest priority data. The data is then retrieved from the last node. The front of the queue is updated to the point to the next node. The memory of the temporary node is freed. Now let's go to the main function. In the main function, two priority queue are created. One for the user and one for the driver. User and driver are enqueued into their respective queue with associated priority. This demonstrates how elements can be added to the queues with different priorities. After enqueuing the data, the content of both queues are printed using the priority queue function to show the priority order. As you can see, first we are calling the function enqueue and calling the function print queue. User and driver are then dequeued based on the priority using a dequeue function. This simulates selecting the highest priority user and driver for a task or service. Finally, the memory is freed for the queue using the free function to clean up and release the allocated memory resources. This code serves as a practical example of managing two types of data, user and driver, in a single priority queue. It highlights the enqueuing, dequeuing, and organizing the elements based on the priority and a common use in many case application.
This is the output of priority queue. So that's all from my side. I hope you all guys understood, and let's see in the next video.